Hari. In this video, we discuss the theorems of moment of inertia. Actually, the theorems are mathematical tools in finding the moment of inertia of the objects. Okay? So let us start with Parallax Theorem. Two theorems are there. First one I am discussing parallel axis theorem. So I consider a rigid body here of mass m, and I want to find the moment of inertia of this rigid body rotating about this particular axis. Then, to find that moment of inertia, I will be considering an axis passing through the center of mass of the body and also parallel to the given axis. That is how we are getting parallel axis. And the distance between the parallel axis we have taken it as A. Then, according to Parallax Theorem, moment of inertia I of the body about the given axis will be equal to ICM, that is moment of inertia of the body about the center of mass axis plus mass of the body into square of the distance between the two parallel axes. So this is actually the mathematical form of what you call the parallel axis theorem. Okay? Now, how to define this theorem? Let us see. Parallax theorem can be defined as the moment of inertia of the body about a given axis is equal to the sum of the moment of inertia of the body about an axis passing through the center of mass of the body and parallel to the given axis, and the product of whole mass of the body and the square of the distance between the two parallel axes. This is the definition. Actually, the written equation I have stated in words, that's all. Okay? Now, to understand how this is coming, I will give you a small derivation for it, even though it is not necessary for the syllabus, say the board exam and all. We must understand how it is. Suppose I consider a small mass particle here of mass small m, which is at a distance x from the center of mass axis, and between these two there is the distance a is coming. So if I define the moment of inertia of this mass about the given axis, I will be getting that small moment of inertia of that small mass m about the given axis as m into a plus x the whole square for the small mass. So if I want to find the moment of inertia of the whole body about the given axis, I will be taking the summing of this small moment of inertias, and therefore I will be equal to sum of m into a plus x the whole square it comes. And therefore I can rewrite this as sum over m into a square plus 2ax plus x square. Nothing but I am expanding a plus x all square. Okay. Now this can be written as sum over m into a square, first part, plus sum over m into x square, that is this one, plus sum over m into 2ax. Sum over m into 2ax it comes. Now this will be equal to, see, this m into a square, a is constant here, and therefore I can write this as a square into sum over m, because a is constant, so distance between the parallaxes, plus sum over m into x square, okay, plus 0, because the 0 is coming, let's take it like this, that 2a into sum over mx, this is what I can write here. 2a is constant, I can take that 2a out, and but sum over mx, m into x can be taken as moment of the mass. This moment of the mass, if I take the mass m here, from this there will be an m into x. Exactly like this, on this side also there will be an m into x. So the moment of the mass sum for all over this body about the center of mass axis, if you consider, it will be 0. This part will be 0, as per it is taken with respect to the center of mass axis. Therefore, what I get here is m into, okay, let me write over here, I equal to, what is this? A square is constant, sum over m. So a square into sum over m is nothing but the whole mass of the body, capital M, plus sum over m into x square. So m into x square all around the center of mass axis, if you take, that will be nothing but equal to center of mass of the body about, sorry, ICM, I could say that sum over m into x square is nothing but equal to the moment of inertia of the body about the center of mass axis, that is ICM it is. So what I get here is I equal to ICM plus m into a square as stated above. Okay, this is a small derivation you can have for the parallel axis theorem. Alright? Remember one more point, that the given axis can be anywhere. It can be passing through the body or passing on the body or away from the body. Anywhere it is no problem. You can apply parallel axis theorem. Okay? Now, as we have understood the parallel axis theorem properly, now we are going to see how to apply this parallel axis theorem in finding the moment of inertia of certain objects. As an example, for that I consider a disk of mass m and radius r. A disk of mass m and radius r, if I assume a disk, this is the disk of mass m and radius r. As you know, when you consider the disk thin disk, the mass is distributed all through the surface area of the, what do you call, disk. Okay. Now, the question is to find the moment of inertia of this disk about a tangential axis perpendicular to its plane. About a tangential axis perpendicular to its plane. So, tangential axis, axis touching the disk but perpendicular to its plane. So, as it is stated like this, I can consider an axis which is tangential and perpendicular to the plane like this. So, suppose this is the given axis, for example. So if the disk rotates about this particular axis like this, right, what is its moment of inertia? Okay. Now we have studied Parallax theorem and how to apply that over here. That's the thing. So we have to consider an axis which is passing through the center of mass of that disk and also parallel to the given axis. So this is where we can assume the center of mass of the disk, and I consider an axis which is passing through the center of mass and parallel to the given axis. So it can be an axis which is like this. Okay. So when I consider this here, this will be I we want to find, and this can be treated as ICM over there. So between these two parallel axes, you can have a distance A. That distance A is nothing but equal to the radius of the disk. Alright. So you understood how the parallel axis can be considered and what is the distance between the two parallel axes and all. Now directly you can substitute in that formula that I equal to ICM plus m into a square. This is the formula for Parallax theorem. Or this is the Parallax theorem. So applying that, you get I equal to ICM, that is moment of inertia of the disk about the own axis. We know that it is m r squared by 2. This is the non-fact, already know. Plus m into a square, a equal to r, which is equal to mr square. Okay, so mr square by 2 plus mr square. So what you are getting there is 3 mr square by 2. So this is what the formula for, or this is the value of moment of inertia of the disk about the tangential axis perpendicular to its plane. Got it? So when you use Parallax theorem, the value of the moment of inertia must be known about the center of mass axis. Then only you can find the moment of inertia about the given axis. That's a very important thing. Another thing is that here we are indirectly proving that the moment of inertia of the object that depends on the axis of rotation. Because earlier we defined this value about its own axis. Now we have defined the moment of inertia with respect to another axis, and accordingly the value is changing. Okay. So this is how we are applying parallel axis theorem in finding the moment of inertia of the object.